All tool shops must perform mold flow analysis prior or in conjunction to the preliminary mold design layout in order to determine the best part configuration. Mold flow reports must include, at a minimum, process parameters used, gate and runner sizes, fill time, fill animation, for each side of the part, shear stress, flow front temperature, weld lines, air traps, injection pressure, pack pressure, warp probability, clamp pressure required. Note, analysis of the cold runner and sprue or the hot runner system must be included to help account for pressure loss. Due to the vast array of resins available, mold flows must use the proper resin specifications supplied by the resin manufacturer, e.g. Dow C719, not generic PP. This information can be obtained from the Amer Program Manager. Filling patterns must be balanced within an individual cavity, as well as between multiple cavities in order to minimize clamping pressure and improve the processing window. The size of the gates, and gate tabs if applicable, must be large enough to prevent premature gate freeze. The freeze time of the gate system should not be less than 75 to 80% of the freeze time for the nominal wall stock. Mold flows must be submitted to the Amer Program Manager for approval before steel can be cut. Approval of the gate and runner system does not remove responsibility from the tool shop to design and build a tool that fills without issues. All mold flows are to be submitted in MFR, 3D, format. Initial MFRs can be submitted using dual domain mesh calculations. Final MFR submissions must use 3D mesh calculations with a mesh size that is small enough to analyze the smallest features on the parts. Mold flow results must also be submitted in 2D on the Amer mold flow study formatted file, unless otherwise specified. Mold flow analysis must verify that the tool can run below 80% of maximum injection pressure and fill speed in estimated press tonnage. The final mold flow analysis must include the actual runner system geometry, the exact geometry as designed in the 3D mold model, all the molded parts produced in a single shot, all cavities, and all the cooling lines as designed in the mold. The runner system and the layout of the cavities must be created in a 3D CAD and imported into mold flow for the analysis of cooling and warpage. Plan as follows. Preliminary mold flow report for the best gate location and tonnage. Final mold flow report as noted above. Updates to the mold flow reports for all the necessary changes as many times required by the Amer tool engineer. Careful design of cooling passages is necessary to achieve the most efficient heat transfer and uniform mold surface temperature. The minimum flow rate for all circuits to achieve efficient cooling as stated below. All water circuits must be leak-free upon delivery to Amer. All water fittings must DME 300 series type or equivalent. All water fittings must be brass and a single piece. All water plugs must be brass. All water baffles must be brass and a single piece. All water fittings must be flush with the outside of the base. Any water fittings on top of mold must have a run-off channel so that any water which enters the bore is diverted away from the parting line. If mold has cavity and core inserts, there can be no water fittings on top of mold. The recess hole for each water nipple must be 1.25 inch in diameter and deep enough for the nipple to be recessed flush. No two water nipples are to be closer than 2 inch center to center. No water fittings allowed in clamp slots. All threads on water or oil lines must be USNPT tapered type. All other threads must be USUNC type. All water, hydraulic, oil, ins and outs to be marked with 1/2 inch tall letters. When using baffles, they are to be 2 times the size of the water line feeding them. The water outlet temperature must not exceed the inlet temperature by more than 3 degrees Celsius 5 degrees Fahrenheit. If the variance is greater than this requirement, more water circuits and reducing cooling line distance is required or complex water circuit design is required. This is our criteria for the cooling line dimensions. Engrave the final water line schematics on the side of the mold. One for the core and one for the cavity as designed in the mold. O-ring seals on the back of the cavity and core inserts for water lines connections are not acceptable. To eliminate O-ring seals, utilize thicker cavity and core inserts and thicker mold base and drill clearance holes in the mold base for connecting the water lines directly to the cavity and core blocks. If feasible, drill water lines on an angle. Follow the part profile instead of using baffles. If not feasible, use baffles as necessary for good cooling system. The following slides shows an acceptable preliminary DFM and mold flow analyses.
Hola México, ¿cómo estamos? Un poquito más, ¿no?